Alrighty, howdy everyone. Um, so welcome to your first review session. I'm Allison Getz, in case you missed that yesterday. But if you're here, or Monday, if you're here, I'm assuming that you know that. So just kind of quickly how I like to run my office hours before we get started. I do call them review sessions because I do like to run this more as like practice problem based. So every week I'll be here from 5:30 to 6:30. I am the IA for Dr. Altimos and for Dr. Bengali. You both are taking, both classes take Chem 107. You should be very congruent with your material. But if something sounds slightly off, you might just be in the other class and you didn't get as far, you got a little bit farther ahead. So that's 5:30 to 6:30, both classes. For exam weeks, I do have this room starting at 5 o'clock, so we can be here from 5 to 6:30 just to give you a little bit of extra time. But every week you can come in with any questions you might have. We'll go over a little bit of what that means, just in terms of like a little lecture first, and then we'll go over some practice problems. I think the best way to learn chemistry is through practice problems. And so I'm here to kind of create some own based some questions off of your homework or something that you may have. So I'm just open to what you need and what you want, and then I will tailor it to you there. Any questions for me before we get started? Okay, cool. Anything y'all want to see today based off of what you've had in class so far? Nothing. Okay, how far did we get in class today if we were in Dr. Altimos's class? Okay. Okay, cool. And then just by show of hands of who's here, has anyone not taken chemistry before, or we all had some sort of background in chemistry? Okay, a couple people. Okay, cool. So if anything just sounds foreign, you have questions, just please, this is very interactive, very informal. Interrupt me, raise your hand, and I'll be able to answer that for you. So we just want to do a couple of basic practice problems that'll help you for your homework for this week. And we'll just kind of go from there. Cool. Okay, so I think everyone can see that. So when we talk about atomic structure and atomic symbols is the first thing that we're going to talk about. Could anyone tell me, right, when we look at the periodic table, there's a letter or letters associated with the element. If we're talking about atomic structures, what's usually the letter that we use if we're just talking about like general atomic structures? X. Yep. So we have X as our atom or as our element. So X here is our element. Your element is not going to change, right? In terms of like what the letter code is. Sodium will always be Na. Aluminum will always be Al. What are other things that we can put around our element? Yep, the amount of protons. And what do we call that? That's the atomic number. And where does that go? It goes in the bottom left. Is there a letter associated with that? Perfect. Does your atomic number ever change for an element? No, right? So your atomic number is never changing. So what does that mean about the protons of an element? Can that change? Right? So your protons are never changing. If the protons do change, you're talking about a different element. So for a specific element, that proton number will always stay the same. So for a specific element, what are the two components that can change in an element? Yep. Your number of neutrons and electrons can change. Okay, and then what's the last letter associated with an atomic structure? A, and where does that go? Good. And what does A stand for? This is your atomic mass, which is your neutrons and your protons. Why don't we include electrons in the atomic mass? Their weight is so small, right? They don't have really, their mass is negligible. So it's so insignificant, we don't need to count them towards your mass number or your atomic mass. Alrighty, so if things are changing, so when your neutrons are changing, if neutrons are changing an element, what is that called? That's an isotope. And what about if your electrons are changing? Good. Do you know what different types of ions we have? Good. So we can have a cation or an anion. What charge does a cation get? That's positive. What does an anion get? Negative. Right, if you think about batteries, you have a cathode and an anode. The cathode is your positive end, the anode is your negative end. So your cation is the plus, your anode is the minus. Right, cat ion also has a T in it, which looks like a plus sign if you're a visual learner that way. If we have a cation, what do we have more of, protons or electrons? We have more protons. So did we lose or gain electrons? We lost electrons. And then if we have an anion, what do we have more of? We have more electrons. So did we lose or gain electrons? We gained electrons. I don't think we covered this yet, but does anyone know what side of the periodic table makes more cations or anions? The left side makes more of which one? Makes more cations. Why is that? Right, it wants to lose its outer ring of electrons. What do we classify the left side of the periodic table as? More general. What's the alkali? What's metals, right? All of those are metals. So metals make cations. So what makes anions? The other side or nonmetals. Metals want to lose their electrons and nonmetals want to gain electrons. So metals lose electrons, nonmetals gain electrons. So if we take a look at the periodic table, I'll tell you this right from the beginning. There's so much information you can get from the periodic table. And you might know some of the information you get right now, but there is a ton of stuff that you can see just based off of the periodic table that you'll learn throughout the semester. So if we look at the left side of the periodic table in that brownish yellowish area, those are going to be like your most common metals that you know of, your alkali and your alkali earth metals. Right, you can see sodium and lithium. Those are pretty common metals that we know of. Those will all form +1 cations, right? They are always going to be a +1 ion when they lose that one singular electron that they have. If you recognize sodium, you probably also recognize chlorine in the green, and those are going to be your nonmetals on the right-hand side. But right, sodium loses 1 electron, chlorine will gain 1 electron as an ion, and that's what makes table salt, right? So by themselves, they're very, very dangerous elements, but together they make something tasty. Okay, so that's the beauty of chemistry. But right, if we look in the red portion here in the center, does anyone know what those are called? Those are your transition metals, good. So in your transition metal section, again, transition metals, those will all make positive cations. They're still metals, they're still gonna lose electrons in order to gain, or in order to create a cation. In the green section, that is going to be where your nonmetals reside. Those are going to be the ones that are taking in those electrons that your metals are losing. So, right, very common is carbon, nitrogen, oxygen, and fluorine up in your upper right-hand corner. This is like the entirety of organic chemistry right there. That's a lot of biological chemistry. I am a biological chemist. This is where I work in the periodic table. So that is going to be what is going to be gaining those electrons and creating those anions. Does anything happen with the purple section on the right? Nope. Those are your noble gases. Those are inert. They don't do anything. You will hardly ever find anything that we're doing with those in terms of like practice problems, because they're boring, except for xenon. Eventually, you'll kind of see that pop up every once in a while. Any questions on like what is forming a cation or an anion and where you can see them on the periodic table? There's a lot more elements that make cations than anions, but that is the fun thing. Any questions? Alrighty. So, right, if we're talking about anions, oh, I didn't switch over. Okay, if we're talking about cations and anions, and we tie this back to our atomic structure, can we write if something is an ion on our atomic structure? Question? Mm-hmm. Yeah, absolutely. Mm-hmm. Yes. Yep. So along what happened? My colors I just put that together. So along the like teal section between the blue and the green, those are going to be transition issues, where they are still cations, but they have more properties related towards the nonmetals. But aluminum would want to lose its 3 electrons before gaining technically 5 in order to create its outer shell. The borderline is carbon, right? Carbon is going to be the first one that's going to start gaining electrons with 4. And it's usually like a maximum of, we say the general rule is a maximum of 4 that you're going to take in. You learn that that's an exception later on. Great question though. But like anything under boron, aluminum, gallium, like all of those will lose 3 electrons. Oh, she's tired too. Alrighty. So back to atomic structures, right? We're talking about ions. Is there a place that we can show that your atomic structure is an ion? Yep, the top right. So here, right, this is going to be your charge. And that will tell you if it's a positive or negative. Is there a letter associated with that? Or is it just a number? I think it's just a pound. Alrighty, any questions on atomic structures? That's the most that you can tell from there. There's never going to be something in the bottom right corner. So if that's an answer choice for some reason, don't fill it in. It's not it. It's not correct. But again, A is going to be your mass. That's going to be the biggest number you see. Your Z is your proton or your atomic number, and that is going to be how many protons are in your element, and that's correlated to whatever symbol is there on your X, right? Those talk to each other. And then the charge is going to be either if it has more or less electrons. Any questions? Alrighty, let's do a couple of practice problems. Okay, so let's try it for these three. We want to write the atomic symbol for the following, which include neutral sodium 23, neutral uranium 238, and then element number 35 with one extra electron, and it's isotope 80 of element 35. Does everyone know that what it means when it says sodium 23? Okay, I see some head shakes. Now, someone that does know, can you tell me what that means? It's your atomic mass. Yep, so this is your atomic mass. So this is saying, does anyone know what the letter code for sodium is? Right, we have Na. So where is 23 going to go, top or bottom on the left? Going to go on the top. This is telling you what the weight of that isotope is. Right, so if you think of carbon 13, right, that's isotope 13. That's telling you that the weight of that carbon is 13, which is different from the typical carbon 12. Does anyone know what element number sodium is? It's 11. Yep, so where does that go? That goes on the bottom. Okay, so if we were to write this out, if we have protons, how many do we have? We have 11. How many electrons do we have? How many neutrons do we have? Good. Okay, so try and do that for the B and C here. I'll give you a couple minutes. Feel free to talk to the person next to you. I'll pull up. No, that'll be given to you on your periodic table. I'll pull that up. You'll always be given a periodic table on your exam, so, and that'll have the mass and the number and the symbol and the name, I believe.
How do you put the neutron?
So the mass number, if it switches over. Yep, so the mass number is 23 and then your atomic number is 11. So we know that the mass number is the sum of your protons and neutrons. So you're just subtracting 23 from, or 11 from 23. Pull the periodic table back up and we'll give you a couple minutes to work on B and C.
Talk about the periodic table, they put like put the atomic number at the top.
So the periodic table is laid out based off of the number of protons, where your atomic symbol is laid out by isotope. So you can have, it's more for like nuclear chemistry. You're going to look at it with the atomic mass on top and then the number on the bottom. Because that will deal with like gamma emission and beta emission, all that stuff. Then your numbers across are going to change. Periodic table is based off of number of protons, so then they just arrange it by that way. Yep. Yep. Yes, so we're talking about the weight of that isotope is 80. Yeah. Mhm.
I did like private but
Mhm.
like and stuff.
Mhm.
And I know you like upload or she uploads like lecture videos, but like I don't, there wasn't anything so far, so like I wasn't if I could just lecture like on
You are in Dr. Bengali's class.
Yes.
Let me see. Let me go to this class real quick. Yeah, they're so it looks like he didn't upload a lecture video for that. But we got to like we got to like his atomic structure was the last thing we talked about. So just this stuff here, just basic like chemical physical property stuff.
Okay.
So that's slide 27. So if you just review that, then you should be fine.
Okay.
Okay. Okay, awesome. I hear some good discussion happening, which makes me think that we're good to go over B. Does someone want to tell me what uranium's element symbol is? U. What's going in the top left corner? 238. And then what's going in the bottom left corner? Awesome. So how many protons do we have? 92. How many electrons? 92, right? Neutral means that there's no charge. And then what about neutrons? And how do we get that? All right, so we just took 238, which is our total mass, subtract it from the protons to get whatever remaining neutrons there are. What do we notice about the number of neutrons compared to the number of protons? It's much greater, right? This has to do with the fact that the nucleus is very positively charged, right? It's only positively charged. So you have repulsion forces in there from the same number of a same charge being very close in proximity. So the more charge you have in the center, the more neutrons you need. So the bigger you get and the farther down on the periodic table you go, the heavier you get in terms of your element, obviously, because you're adding more stuff. But the more neutrons you need in order to keep that nucleus together. So you'll see that you need a lot more neutrons the lower on the periodic table you get. Any questions on uranium? And then what about C? What is the element here? What's the letter for that? Good. Going in the top left? Perfect. Bottom left? Awesome. Anything else we need on this? Perfect. We need a minus on the top right to show that it's a charge. That's an anion. What kind of, well, I gave it away. This is an anion, obvious, because I said so. Right, and that's because it's a negatively charged ion. How many protons do we have? 35. How many electrons? 36, right? We have a negative charge, which means we have extra electrons now. Because we have a negative charge that means we have more electrons than protons. So we need to add an electron to the number of electrons we have for this specific isotope. Yep.
We get one extra electron, we do have.
Yes, right. So if we were talking about like this element is -3, that means that it has 3 extra electrons. It does not matter if it's 3 minus or -3. Either one is fine. Yep. So that just means it's the same element, different number of neutrons. Yep. So all of your isotopes, right? So if you think of like carbon 12 and carbon 13, those are isotopes of carbon. They're both carbon. Carbon 13 just has an extra neutron. Alrighty, any other questions on the number of electrons? How many neutrons does bromine have? Right, we can see here that there are only 10 extra neutrons in comparison to the number of protons, when in uranium we have a plethora of neutrons in comparison to protons. I can't do that mental math right now. Alrighty, any questions on atomic structure? Okay. Any more practice you want to do with this? We feel a little bit more comfortable. Yeah. Say it again. N and in what context?
Well, I mean, I learned something on the side where it's like, you basically make a triangle and it kind of shows the protons, neutrons, and electrons.
I don't think I've ever heard of that. Has anyone else heard of that? If you show me an example, I can try and figure it out. Sorry, that's a new one for me. Learn something new every day. There was another question. Yeah. Sig figs, absolutely. Like general rules and stuff for that. Yep. Yep, absolutely. Has anyone not heard of sig figs? Okay, that's a good starting point. Okay, So sig figs are going to be your best friend, I promise. And then the more you use them, the more you will be able to understand them and know how many you need at the very end. Along the way and along the semester, I will give you a little bit of like tips and tricks on how to kind of solve them and what you need to do them at the very end. A lot of the times you can get how many sig figs you need just based off of your original question and the stuff that you're given. But for general rule of thumb, we have sig fig rules for addition and subtraction. Does anyone know what that rule is? The least amount of sig figs, and what were you gonna say? What was the other? Yep, so least amount of places after a decimal point. Right, so if we're looking at (1.001 minus 1.01), how many sig figs does 1.0001 have? This has 5. How many does 1.01 have? This has 3. We're gonna change this to. Don't have to. Right, so we have 5 in 2, and we have 5 in 1. So if you were to subtract this, how many decimal points are we gonna go to? 2 decimal points, 3 total sig figs. Right, so we would have 1.09. Guys, it's Tuesday, the semester started. Don't judge me for using my calculator. It's Wednesday. I'm telling you, guys, I've used my brain all day today. Please bear with me, right? If we do this math, it's 0.9901. So how many decimal points are we going to? 2. So where are we rounding this to? 0.99. How many total sig figs do we have in our final answer? 2.
Would we write like 0.990 instead of 3 sig figs?
No. Nope. So it doesn't really, so for addition and subtraction, it does not matter how many you start with, right? We started with 5 significant figures. We started with 3 significant figures. We're ending with 2 significant figures. The most important part is how accurate your number is. So the 1.01 is only accurate to the second decimal point. So our final answer can only be accurate to the second decimal point. If we added a 0 afterwards, how many sig figs would be in that answer? It would be 3, right? Because anything after your first non-zero is going to be significant. So if this was, right, 0.990, this 0 now becomes significant. So this has 3 sig figs. That's too significant for the math that we had beforehand. Okay, so this does not work. We want 0.99. The least number of decimal points. Yep. Nope. So if this was, right, do that again. We still have 5 sig figs. We still have 3 sig figs here. We only have 2 decimal points. That's what matters most, right? For addition and subtraction, the only thing that matters is how many decimal points you have. So your final answer can only go to 2 decimal points. So this rounds to 1.99. Okay.
Do you round or just like chop?
You would round. In this case, you're rounding 0 and 9. So the rounding, right, doesn't matter. But if this was, right, if it's 1.995, are we rounding up or down? We're rounding up. So what does that turn into? 2.00, right? We can still be accurate to 2 decimal points, but now both of those zeros are significant. There's still 3 sig figs in 2.00, but now it's just significant. It's still only accurate to the second decimal point. Does that make sense for addition and subtraction? Yes, okay. So, right, you can identify how many sig figs are in the beginning of both of your numbers, but the main thing with addition and subtraction is how many decimal points they are accurate to. Okay, what about multiplication? What is this rule for this one? Yep, this is lowest number of sig figs. Okay, so if we have 2.0 times 4.00, how many sig figs does 2 have? 2. How many sig figs does 4 have? 3. What's going to be well, how many sig figs will our final answer be? 2. So what is that final answer? 8.0, right? We need two significant figures. So we need a decimal point after our significant, after our, even though it's 0, we still need a decimal point after that decimal point. We need a decimal placeholder after the decimal point. Question.
Well, let's say you have like, 3.0 times 50. But in that case, like your total answer is 150, but you have 2 significant figures. How would you?
Great question, right? So we have 3.0 times 50. How many sig figs are in 3? We have 2. How many sig figs are in 50? 1, right? There's no decimal point after 50. So that first 0 in 50 does not count as significant. It's only significant to the tens place.
If it was like 50.0, would that be like 3 significant figures?
Yep, so right, we said that 3 has 2. This is a point. How many does 50 point have? 2. How many does 50.0 have? 3. Right, so the answer for all of these, we said, is 150. Question? So scientific notation here is not going to help you, and I'll show you that in a second. So for our first one, we have 150. How many sig figs can we have in our answer? 1. So what do we have to do to it? We have to round. Are we rounding up or down? Up to what? 200. So this becomes 200. Yep. Well, that's a problem, right? So that's why we want very accurate measurements so that we have the most significant data and the most significant number. Okay. For our middle answer, we have 150. How many sig figs can we have? 2. So do we do anything to this one? Nope. This one stays at 150. And what about our last one? How many sig figs do we need? 3, right? Sorry, we need 2. We need 2. Good answer. So what do we do to 150? It's nothing. It's just 150.
So when you take a measurement, you just add the decimal. When can you add the decimal?
So when you are taking, like, if you're in lab, you will have 2 balances that you're using. You'll have an analytical balance and then the other benchtop balance. The analytical will be accurate based off of how many like digits it's reading out to you. And so that you just take as is. Whatever you get on your balance in lab, that's how significant it is, and that's how accurate it is. The analytical balance is usually accurate to 4 decimal places, and your benchtop is usually accurate to just one. So you can't add any more numbers because it's just what's given to you there. It-
In the second example, you have the decimal point of 50.
Mhm.
When are you allowed to include?
It would be given to you. Or if you needed something to have two sig figs, then that's when you use significant scientific notation. Yep. Yes, if that was like 3.00, and then, right, so if we had a fourth example of, right, if we had 3.00 and 50, this would be 3, this would be 3, so our answer would be 150. Period. Yep. Yep.
So if I had like a, 12-inch ruler,
Mhm.
I measured something to like a 9-inch mark, that would be 9.0.
Yes, you can go to one extra spot. So if you have something that, right, is 9 inches, then you know that it is 9.0. If you're at something and it's 9.5, then you can say it's 9.50. You can always go one extra significant spot, because that's like you're guessing how significant it can go. But you know it's accurate to that measurement, and then you can make one more assumption. Great answer, or great question. Yep. I believe in your homework, it wants you to do the operation and take into account your sig figs there. And then if you do the next operation, take into your account the sig figs there again. So if you had to do multiplication first, you take into account however many sig figs you're starting off with. Then if you have to add in something later, then you do take your sig figs there again. Right? So you have to like compound your significant figures. When you get later into practice problems, and when you get later into chemistry problems, you'll be given 4 numbers in your question. If you find this number here that's given to me has 3 sig figs, your answer is probably going to be just 3 sig figs at the very end. Mostly for your homework right now, you just have to pay attention to what operation you're doing. Question. Yep.
So if I have a home equation, it's like 10 times 2 plus like 9.09.
Mhm.
So I multiply 10 to, I just go to one sig fig.
Mhm.
So I just have to put 20 in, right?
Yep.
And even though since 10 only counts as does 10 count as one sig fig or 2?
It depends on how it's given to you. If 10 is just 10, it's 1 sig fig. If 10 is 10 period, then it's 2 sig figs. Yep. Question.
I read something like that, it's like measurements have like sig figs.
Your given value, so like your standard numbers are infinite values. So your like temperatures, if they're 273.15 Kelvin, that technically has 5 sig figs, but because we know that that is a standard temperature, that has infinite sig figs. You don't need to worry about that one. Any like at the speed of light, 2.998, that one is infinitely significant because that is like a standard number. Measurements in terms of like, I weighed this on a bench top and got a measurement, that is significant because the instrument itself is only accurate to a certain amount.
Is there anything that I can just like say, oh, this is gonna be infinitely significant, but this is not?
If the value is on your reference sheet, it's infinitely significant. Yeah. And there'll be more along the way when we do practice problems. Like once you see more actual word problems, it'll be easy to point out and say, okay, this one's going to be infinitely significant. We don't need to worry about it. Any other questions right now? So if we were to say, this operation here. what are we doing first? We're doing division first, right? We have to follow PEMDAS. So what are we looking at in terms of our significant figure rules? Good, we're looking at just two sig figs, right? We have 10.001 divided by 3.6. This has 5 sig figs, this has 2 sig figs. So we get an answer of 2.778055. Close enough. Right, so what are we going to for significant figures? 2 sig figs, so what's our final answer? 2.8, so this goes to 2.8. It now becomes 123 plus 2.8. What does this operate? What are we looking at now? Least number of placement values, right? What placement are we gonna go to? Just the decimal, right? We just need to round to the ones place. So we end up with 125.8. What are we rounding to? This has to go to 126. Here, it doesn't matter. If this was rounding to a 0, then yes, because then you would need to have 3 significant figures. But because all of these are non-zeros, it doesn't matter. Do we see how my biggest takeaway from this is that when you're doing your homework, be the most accurate first, get your answer, and then take into account significant figures. Do the same thing again where you get the actual answer and then take into account your significant figures, right? Do your rounding at the very end. Yep.
So they're like standards, like typically, I've seen some places where like you use the full decimal answer, do like all your computations and then do things like once a day.
Yeah. So when you get into word problems, like when you start, the next thing you're going to learn about in lecture, right, is going to be this isotopes, and you're going to talk about percent abundance. Those are accurate, usually like 3 or 4 decimal places. And those types of questions, I would typically do your significant figures at the very end. Keep them all for as long as possible, and then just make your final answer at the very end.
So like this big carry 2.772.
Yep, you could carry that all the way down and then do your stuff at the very end. For your homework, they want you to do it stepwise. Yep. Yes, yep. Yeah, I think it's correlated to your textbook. So chapter 1 just might be like intro or something. But yeah, it's whatever is due first. That's what is necessary. Yep. Yes.
So what, so our homework says do like the end of the week.
Mhm.
For chapter 1.
Mhm.
So will it be due like every week by the end of the week?
I believe so. Or what professor do you have?
I missed, on Tuesday.
Tuesday, Thursday, so you have Bengali. So if you look at his course schedule, it'll tell you, like it says on, if you look at that button of course schedule, Sunday, August 25th, it has homework due at 10 p.m. If you click on that homework link, it'll take you directly to OWL and you can see what's due there. And so if you just follow that, right, next Tuesday, September 3rd, yeah. So Tuesday, September 3rd, homework is due. So instead of it being due on the holiday, he has it due after the holiday, right? So if you just follow that, then that is when it's pretty much every week besides when you have an exam. There is a lot of homework in this class, but I promise it's helpful. Yes, yep. But usually like the one assignment has 3 sections with 3 questions each. And like I look at them, I did one today. The first, if you click on that first one, it's like just the isotope. So basically the first 3 questions that we did today, you just repeat that a couple times to make sure you got it. Yeah, so I think you get 3 attempts at your question. So as long as you get it right by the 3rd time, I think then you get full credit. And there's a lot of it, so even if you don't get something right the first time and it takes a little bit of points off, like it'll factor in and work out in the end. Don't worry about it too much, right? Yep. Your grades in this class come from the homework, your coming to class and your iClicker points, and then like your weekly quizzes and then your exams. So as long as you get your homework done, that's going to be a good chunk of your grade.
Is that like completion based or is it like I think he took it off bachelor's? Is that like actual completion?
He's just grading it to show you that you have a grade and your stuff is working. At the end of the week, he's going to wipe those and those won't count. Yeah. Yeah, this week for both classes is just participation. I know Bengali's grading them just to so that you get a notification or something, so you can see like, yes, my iClicker is accounting and working. But we will wipe those and that will start taking into account after the Q drop or the drop deadline.
You only get credit before you get credit.
You will get credit for being in class and answering, right? If we only have one iClicker credit or iClicker question that day, say you get it wrong, you'll get credit for being in class, but then you will not get credit for the correct answer. So it's like, no matter what, if you show up to class and there's an iClicker, you at least get 1 point for the day. Any other questions? I am not. So I only deal with lecture. I taught Chem 119 and 120 lab my first semester here, so I do know the labs, but I've mostly been a lecture IA since. You'll should meet your TAs eventually. Yep. I believe so. I could log in right now, but I think that's most of it. I think you'll do a couple of percent abundance on like Thursday or Friday, depending on who you have. And that'll be like the last little bit of your homework. But they do a pretty good job of explaining that in class, so hopefully you get that one. Yep.
So on the chapter 1 homework, I saw that it asks you to do some conversions.
Mhm.
How many of the, like, I know how to do the conversions, but I don't always know the, like,
Sig figs for that one.
no, not sig figs, like what the number, what you're like.
Converting between, like, if you want to go from centimeters to inches or something like that, right?
I don't know the number.
Yep. So you can always look that up. You're not gonna like lose points for that. No, you don't need to memorize that. I don't know if they give you a reference sheet yet.
I saw it on the.
Yeah, so you'll get a reference sheet for your for all of your quizzes and all of your exams. And that'll have your necessary conversions. Right now, just look them up. You'll be given them. And then any number that you need to convert with, besides like, I think, like a kilometer to a meter, right? That thousands you're not gonna get.
You have to memorize those or.
I believe they give you those. The more you work with them, the more you understand them though. Yeah. Yep. And that'll come back quickly. But I do believe they give you like the small ones. They'll give you the conversions for those. They give you a lot more than you think, I promise. Are there any other questions with sig figs or yeah? There's no labs this week. Nope. Nope. Honestly, I don't even know if the TAs have the assignments yet. So it's any other questions? Yep. Absolutely. Yeah, that's no problem. You can come up afterwards. Alrighty, well, if that's it for today, thanks y'all for coming. I'll be here every Wednesday. Once we get a little bit more material, I'll have some more practice problems available that'll be like in-depth problems. But if you have any questions, feel free to email me at any time. I'm usually pretty responsive with those. Someone did email me and my laptop didn't connect to the Wi-Fi until today. So that is that. Yeah, thanks so much. See y'all on Friday, I think, if you're in Altos class.
I was the one that's emailed you about the slides, like. it
Yes,
wasn't
yep.
working. I don't know if I'm just like stupid, but I click on it and then I like go through the whole process with Engage and like it doesn't.
Okay, let me see. I emailed you back today, but my Wi-Fi in my lab was not working, so it would
Okay.
like could not connect, and I was like, great.
Okay, I think I actually got it.
Oh,
maybe, but
okay.
I still like tried it and it still just wasn't working. It
Okay.
worked like the first day, but not the other day.
Um,
Yeah, because it didn't take me to that site during class.
I'm thinking this one, this is also Cengage. Interesting. If you click on that
You
right
just click on
one,
that,
yeah,
and is that it for all of them?
I believe, right, because that one doesn't have a thing yet. This one still brings you to Cengage.
Okay.
I don't know what you know what this is probably doing? This is my first time working with him, right? Because he's
Okay.
his first time on campus.
Yeah.
So I think what he has linked here is, right, Unit 1 Matter. If you click on this is going to be the learning objectives
Okay.
for Unit 1, right?
Mhm.
So anything that you need to learn for Unit 1. This, I'm gonna guess, brings you to the textbook in OWL or
Okay.
in Cengage, right? So this will take you to that chapter that we're talking about
Mhm.
for this.
Okay.
Right, so that's what we covered in the textbook. This is the correlation to the textbook.
Okay.
These are the slides that you're looking at. that you
Okay,
can
so,
download.
but like those two things are in there, or like, the slides cover.
This,
stuff.
these slides cover what's in here.
Okay, and then also the box below, like it'd be both
Yep,
those.
so this
Okay.
slide covers what is covered here.
Okay, awesome.
Yep.
Thank you so much.
I think that's what's going on. So then when
Okay.
it comes to next Tuesday, he'll change
Link
this to
that.
a hyperlink and then you can download
Okay,
those.
and then one
Yeah.
more random thing, with the homework, can we
Mhm.
like go in and out of it, or is like when we start it, we have? to
Oh, you
finish
can go
it?
in and out. Yeah, that's no
Okay,
problem.
perfect.
Yeah.
Thank you for all your
Yeah,
help. It's been
absolutely.
awesome.
Yeah, absolutely. Hi,
I just wanted to introduce myself.
Hi.
Nice to meet you.
nice to meet you,
And then-
Allison.
And quick question, before the classes, what do you recommend doing to prepare, like for?
So, I mean, like when I took chemistry, I didn't prepare at all. I just made sure I had my slides downloaded. So everyone just get my announcement yesterday about that? So I think I put it in here.
Like, should I be doing any reading or?
Yeah, so I don't think so. I don't think it's really necessary.
Yeah.
So as long as you have those lecture slides downloaded, I think it's either tablet, physical copy, it doesn't really matter.
Yeah.
But as long as you have them downloaded, what I do is I then like write directly on the slides.
Okay.
So, right, then you don't really need to read it because you're not really worried about
Yeah.
reading what's on the slide. It's right there in front of you. You can just listen to what he or she is saying and then write down like any additional notes to that. If you want to prepare, you can read through the week 1 slides and then see like, okay, this is what we're going to be looking at. Stuff might be totally filled in or stuff might not make any sense, but at least you have it all there. But I think having a physical copy, whether that's tablet or piece of paper, and then writing directly on the slides is going to be more than enough.
And then for the
preparedness.
iClicker questions,
Mhm.
are those gonna be like the same, like, so we're graded on accuracy and on completion for those?
Yes, yep.
Okay.
Yeah, so as long as you are there for class and you answer the iClickers for the day, you'll get credit. And then you're also additionally graded on how accurate you answered the iClicker questions.
Okay,
Yep.
sounds good. Thank
Yep,
you.
no
so
problem.
much.
Oh, my name's
Hi, Allison. Nice to meet you.
And I have 2 questions. One is, I haven't taken like I haven't taken chem since like 10th grade.
Mhm.
So I'm like a little bit nervous. Is there anything like outside of class I can do?
Yeah, I think this class does a pretty good job of like introducing all the topics that you need to. You just might be one person that might need to read the textbook a little bit more, or just go try and find like a little bit of like Khan Academy or something, just to get like a refresher of what's going on with the class. I think I took like a year off between high school chemistry and then undergrad chemistry. And then once you start hearing the topics again, they kind of like ring a bell at least a little bit, couple buzzwords. But I think if you just keep up with the lecture slides and you keep up with the homework, you'll be fine. Being able to read the textbook is also a good additional thing to do. And then just finding additional practice problems outside of class or outside of homework, I think would just be beneficial. And then any of the free help is going to be really helpful too. Yeah.
And regarding the free help for the SI sessions,
Mhm.
I know she has like 3 different sessions, so it's like
are is the thing she covered in each section different?
I think so. I think she does hers, right, more of like, okay, she has it on Sunday, so she's gonna cover stuff that happened in class prior to that last class. So she had one on Wednesday, and then you had class on Thursday, and then she has her class in on Sunday, like it'll be focused on whatever was covered on Thursday. And then if she goes on Monday, then it might be slightly different or whatever than Sundays, but probably a little bit, probably similar than to the Sunday one. But I do think it changes depending on where you are in the week and like what you've covered in class so far. Yeah,
Thank you.
absolutely.
Heading to what I was talking about was this.
Okay,
My brother taught me this. He's a senior in college right now.
okay,
He took OChem, so he taught me a lot of OChem. So
Mhm.
like my brain was focusing on OChem. That's why I was like,
okay,
it rang the wrong bell.
okay,
That's what happened.
okay.
But like, can you explain this to me?
So
Because I got it from here.
so this is just a compound.
Mhm.
This is isoprene. It's not necessarily an isotope. This is just when we do OChem, right, iso is a word you could put in front of a different, type of a similar compound, but different, right, like the bonds might be slightly different. So this is just a different type of butadiene. So this is not necessarily an isotope where you need to say like this is more neutrons or more, or there's gonna be more or less neutrons in it. And the head and the tail here is just based off of where the double bonds are.
Okay. So if it connects to the one, then this would be the end of the tail.
Yes.
Okay.
But that shouldn't really come up at all within, within your classroom
Alright,
this
that makes sense.
semester. Yeah,
Thank you.
it'll be more organic chemistry stuff.
You talked, well, other people talked a little bit about homework.
Mhm.
I'm in Bengali class.
Mhm.
I don't remember us talking.
So if you,
Do you know what's due when?
yep, so if you go to his, Canvas page, and then on his course schedule, it has, right, Sunday here as homework, and it has a hyperlink to the homework here, and that'll bring you directly there.
Okay, that's everything.
And that should be everything that's due for Sunday. Yep.
Okay.
I believe if you sign in, I might need to get an email. So if you look at this here, right, this is all due the 25th. So
Okay.
these couple assignments here are is due for the homework. I
Okay.
think he's gonna talk a little bit more about this tomorrow in class, just based off of like what you have to do for it. They're fairly easy. There's not many questions. It shouldn't take you very long. But that's where you get all of
Okay.
that from. Yep.
But I saw it and I was like, we didn't talk about any of this.
Yep.
But thank you.
Yep, and I think he'll talk a little bit more about it tomorrow too. So, and if you don't know where that's from, just send me an email. I'll try to help you out.
Okay.
Yep.
thank you.
You're welcome.